Uh, Good afternoon, dear students. I hope I am audible. And my screen is also shared, I think. Okay. Please acknowledge. Yes. Thank you. Okay. Dear learners, welcome to the fifth session on the theory course of Fundamentals of C. My name is Shirish Nagar, and today we are going to discuss about input-output operations. Also, we are going to discuss different type of instructions in C language. So, till the last session, we have discussed several topics about the different type of the operators, and we have also seen different format specifiers. Okay, what are statements, literals, variables, concept of variables, and the constants, how memory gets allocated, what are different data types we have seen, right? So the guidelines, as you are all aware, is to make the session more interactive, to maintain discipline for smooth conductance of interactive live session. All the learners are required to type in their name with enrollment number and program name to mark their attendance. You can raise your queries after the completion of session, and uh, the learning objective for the session is introduction to basic input output instructions in C programming. What are input output instructions? What are format specifiers? What are instructions? What are different types of instructions? Then we will have a look on data manipulation instructions and decision control instructions. So this is the learning objective for this session. Okay. So I have already discussed, although different type of input output functions. So what are input instructions or input functions? So input instructions are basically responsible for capturing the user input, which is entered through keyboard or mouse from the screen. Okay, so there is a terminal window, there is which is called uh, it is called console, and on the console, that black screen, that output screen which you normally see, it is called terminal screen. And that on that screen we normally type input. So if we want to capture that input, you would require a function or an instruction for that. So such an instruction which can capture the user input is called input instruction. For example, in till the last lab sessions and theory sessions, we have been discussing about scanf. Okay, so scanf is a function which you can use to take the user input. Okay, so but there is a f which is added at the end of scan word, which means that it requires a formatted input. Formatted input means based on the data type, which value you want to store in which data types variable. According to that, you have to format. And for that specifying format, we use format specifier. So format specifier, I have already told you several times about with respect to different data types. Like for character, we use %c. For integer values, we use %d. For float values containing decimal values, we use %f. For string, we use %s, right? Similarly, for double, we use %lf. Okay. Apart from that, there are other format specifiers for unsigned integers, that is %u. For hexadecimal value, we use %x. Likewise, we have got many format specifiers specified by C language, okay, which we are going to learn shortly in detail. So there are formatted input instructions and we have got unformatted input instructions. So in case of unformatted, there is no requirement of specifying these all format. Okay, so you can input data without specifying format. So if you do so, then your input instruction will be called as unformatted input instructions. Okay. So input means you are feeding some information or some data into your program. That is what you call as input. For example, add two numbers. So which two numbers you want to add? So those two numbers, if you are capturing via scanf, those two numbers will be termed as input for your program, right? So these are called input instructions. Then we have output instructions. So output instruction will be responsible for displaying output or printing any value on your output device. So your output device is normally your screen or the terminal window on which output is displayed. Okay. So output also can be printed on a printer. So printer is also an output device, but normally we don't do that. We first of all display the output on the screen. So for output, we use functions like printf. Okay. So printf is the most commonly used output function, which we normally use to as output instruction. But since we are again using this letter F here, it means that the output is formatted. Formatted means it is according to the data type's value or the data type of the value. So if you are going to display an integer value, then you have to specify the format in quote marks like %d. Similarly, if you want to print a float value, then you have to use its respective format specifier while showing the output. So that is why scanf and printf both have this letter F at end. It means formatted output. But on the other hand, we have also similar to input instructions, unformatted output instructions present, which we are going to learn shortly. Okay. So these are all different types of input output instructions which are available in C language. We then till now, I hope things are clear to you. Although you have attended lab sessions, so you have used these instructions several times. So if we talk about where these functions are defined, because if it is a function, its definition or its operation has to be like coded somewhere. So if we talk about functions like printf, scanf, or other input output functions, they are present in the library stdio.h. So stdio.h stands for standard input output library. And here .h is the extension of the library file. It is also known as header file. So it is header file because it has to be mentioned at the top of the program. Before the program your program starts, you have to define this header file. You have to mention the name of this header file by using include, using hash include. So hash means pre-processing. Pre-processing means before your program gets compiled, it has to take into account the function definitions present in this header file. This is what you call as pre-processing. So that is why we mention all the header files with the help of preprocessor symbol. It is called preprocessor directive. So preprocessor directive allows you to include pre-compiled files because there are certain functions which are predefined in these files. And one of those header files or one of those library files is standard input output library, which is a short form whose short form is stdio.h. Normally students write in exam studio.h. It is not studio. It is stdio, means standard input output. Okay. So please be very clear about what you are writing. Otherwise you will get an error in your program. And also your answer will not be evaluated. Okay. If you write wrong words. Then printf and scanf. So I have already told you about printf and scanf, right? So printf is an output function and scanf is an input function. So printf means it is used to display formatted output on the console. And what is how this function has to be written? So first of all, you have to mention in quote marks the format specifier. So format specifier will be the first argument of the function. Argument means value which you have to pass in the function. And the second argument will be the variable's name. Okay, or the value. So whatever variable or whatever value you want to print, before that you have to specify the format specifier in quote marks. So that is why it is called formatted output function. In the same way, if you talk about scanf, so in scanf also the same pattern is followed. The first argument is your format specifier, which you have to pass in quote marks, followed by the address of the variable, means where you want to store that value. So address of operator, this ampersand sign that you have been using several times, this operator is called address of operator. Address of operator means you want to store it at the address of any variable, because variable is a memory location whose address will be used to store any value captured from the user. So whatever user enters, it is a value, and you have to store the value at whose address? Variable's address, due to which we are using this ampersand sign, and it is called the address of operator. So address of operator like allows you to store a value at a certain address of the variable. Okay, so here we use scanf, right? I think this is clear to you. Many of you have already been studying C for some time, so they know it. Okay. So then we talk about unformatted input output functions. So unformatted input output function, the first one is getS and the second is putS. So getS putS, as the name indicates, there is after get we have got S letter, and after put we have got again S letter. So here both these S values means string. So we don't need to specify any format because the format is clear. In the name of the function itself, we have written what type of value we are input or output. So that is a string. So the data type is fixed. So since the data type is fixed, you don't need to specify the format specifier. Okay, so what is getS? GetS is a function used for reading a string of characters from the console. Similarly, the putS function is used for outputting a string of characters to the console. So a string of characters means it's a string. Okay, since it is a string, the name of the function end with S. GetS and putS. Correct? So here, how do you refer a string? I have already told you in the first lab example also. We know that a string is an array of characters. What is an array? Array is a collection of values having same data type. So if a string is a collection of characters, every single element in the array will be of type character. So if you write anyone's name, let's say if someone's name is XYZ. So X is a character, Y is a character, Z is a character. But since all of these are characters, we are going to store them together as a name. So for that, we use quote marks. So if I write a string like this, it is internally represented like this. And at the end, there is a null character which says that your string has ended. Okay. So this symbol, it is not 10, it is a /0. So this /0 is called a null character. So null character tells you that, okay, the string has ended. So there are now 4 elements in this array, X, Y, Z. So, and every element is a character. So if you want to access X, it will be X in single quote marks. Why? Because it is a character. Similarly, if you talk about Y, Y in itself is a character. Z, Z is a character. Null character is a character. So all these characters when put together forms this string XYZ. You don't need to write null character at the end because it is obviously interpreted. Okay, so here what we are doing in this program, we have declared a string of size 35 characters. So the maximum number of characters this string can have is 35, including null character. Okay. So now I am like asking the user to to enter a string. So enter a string means I am reading that value. So if I'm reading that value, what type of function do I need? I will need an input function. So getS is an input function. So whatever value the user enters, it will be stored in which variable? str variable. Str is what? It is a character array. It is a string. It is a character array. So if the user enters xyz, the value of str will become xyz. Okay. So the value of str variable is now xyz. Why? Because with the help of this input function, we have captured this value and stored it in str variable. That is what input function does. Input function, what it does, it takes the value from the screen and it stores into its respective variable. Whatever you pass as an argument, it will store there. Okay. So here I don't need to mention the data type of my variable. The data type of my variable is fixed, that is a string. In the same way, I am now displaying the value what I stored in this variable str. For that, I need which type of function? I need output function. So output function here is putS. So putS, I will pass argument what variable I want to print on the screen. I will specify that variable. So it will print here x, y, z. Clear? So this is how this program will work. Okay. So those who want to try, they can take a screenshot of this slide. Right? Hopefully this is clear to you. Okay, so now we talk about the other input output functions. They are also unformatted. So similar to get s and put s, we have got for character getChar and putChar. Okay, we have got getChar and putChar. So getChar, putChar functions, what do? They can read a single character and they can output a single character. Okay, they read a single character from the console and output a single character to the console. Right. So what we are doing here, there are two ways to read a character. Either you declare an integer type variable or you declare a character type variable. Both will work in the same way. If you talk about character type variable, it will take arguments like values enclosed in single quote marks. But if you use an integer variable for storing character values, it will translate this integer variable or integer value into ASCII code of a certain character. So if you input 65, it will translate it into A, because 65 is the ASCII value for A. So both are interconvertible. You can convert 65 to character and you can convert character to the integer. Both are interconvertible. So this is called type conversion, which is implicit. Implicit means internally it will translate integer to character and vice versa. Okay, so here we are using integer type variable for capturing a character value. That is allowed in C language. So here what we have done in this program, we have declared an integer type variable called C. Okay, and now we are asking the user to enter a value. So enter a value means we are using getChar function. So whatever the user types a single character on the screen, it will store it in our variable C. So let's say the user enters 65. So the value which the character C will have will be 65. Okay, so 65 will be used to capture a character value. Okay, and then printf you have entered. So now when you use putChar, it will translate it into its respective character value. So it will display A. Okay, because it is going to display a character on the console. Clear? So this is how you can use getChar and putChar to enter a character or a numeric value. And you are also allowed to enter a character like A. So by using getChar, you can also type A. So C will have now value as A. Because how C will have value as A? Because internally it will translate A with 65 and the value of C will become 65 internally. Because the data type of C is integer. Okay, but if you are using this integer to be printed as a character, it will find its respective mapped character value. So it will print A on the screen. Is it clear to you? Is this program clear to you? If you focus, things will become clear. Okay. Okay. I don't see any acknowledgement from the learners, so I think things should be clear to you. Okay. Fine. So again, we come back to format specifier. I have told you several times these format specifiers. %d you have been using as integer format specifier. Okay, you can also use %i, that is for also integer. %c is for character. %lf, lf here means long float. Okay, so that is, there is no %d for double because %d is booked for integer. %f you have been using for float. %hd is for short integer. %li is for long integer. Okay, %u is for unsigned integer. %lu is for unsigned long integer. %lli is for long or long int. %llu is for unsigned long integer. %lf is for long double. So here we cannot use lf because lf is simply double. Okay, so what we have done for long double, we have used capital LF. So there is a difference between small lf and capital LF. So %lf is double, small lf is double, and %l capital and f is long double. Okay, so I guess you are able to understand this. %c, both %c is used for signed and unsigned integer, unsigned character, sorry. And then we have also called a %x is for hexadecimal values, %o for octal values, and we have got no percent s for string. Okay, so these are all other format specifiers which we normally use in scanf and printf statements. Okay, so %x and %o are used for displaying hexadecimal octal value. Hexadecimal is normally used in case of memory locations. Okay, so for memory locations, we can use both %x as well as %u. If you want to display the address, the memory locations address, in that case, you can either use %u or %x. Is it clear? Right. So here, when we talk about instructions, so instructions, what are instructions? Instructions are basically commands which tell the C compiler what to do or to perform any specific task or any specific operation. For that, we normally provide an, an instruction. So if you want to add two numbers, we use an arithmetic instruction as plus. So this instruction can be used as symbols, and those symbols are called operators. In terms of a symbol, we use these instructions, then they are known as operators. So if you look at the structure of your C program, it is like this. So this is how the instructions can be present. They can be declaration instructions. There can be execution based instructions. Okay, there can be directive instructions. Lot of statements we write in our program. More or less, many of them can be classified as instructions. Okay, so here there are basically three types of instructions. When we talk about the instruction types, there are three categories of instructions. First is called type declaration instructions. So type declaration instructions are basically keywords which declare the data type of any value or any function. Okay. So these are called type declaration instructions. For example, int, char, okay, float, double. These are again type declaration instructions. Then we have got arithmetic instructions. Arithmetic instructions for we have for arithmetic operations like addition, subtraction, multiplication, division, modulo. These are all arithmetic instructions. Then apart from with arithmetic instruction, there are other category of instruction called data manipulation instructions. So we are going to discuss data manipulation instructions, which include logical and shift operations. Okay, logical and shift instructions, arithmetical, logical, shift instruction, then then relational operators are there. Okay, so these are operators are there. Then we have got ternary operator, which one of the student has asked what is ternary operator. So then we have got control instructions, which like alter the flow of control or the control flow in the program. In lab sessions, we have used if else, if else if. All those can be classified as control instructions. Also, there are looping instructions. So looping instructions are also a part of control instruction. So control instructions are basically of two types: decision control and flow control. Okay, so decision. So these are two different type of control instructions. Okay, so we will come to each of these instructions one by one. First, we discuss type declaration instructions. So type declaration instruction, as I've told you, is used to declare the data type of any variable, which we are going to use in C program. And every variable should belong to uh, a data type. Okay. So the data types are of three types. There are three ways in which we can mention data types. Primitive data types, there are five: character, integer, float, double, void. Okay. In integer, we can have long integer, long integer. Okay. For float also, for we don't have long float, we have got double. Okay. So the long version of float is double. So in double, we can have long double. Okay. We can have long double. There is nothing like long character or long void because characters are limited. Characters are limited in number, and void does not have any data type associated with it. So there is no modification of this. For character integer values, we have got signed, unsigned. Okay, so we have got signed, unsigned, which will have a sign value, which won't have sign values like this. So here, these are known as primitive data types. So using these primitive data types, we can create another category of data types called derived data types. Derived data types are array, pointer, and functions. And then we can have user-defined data types. So user-defined data types are enumeration, structure, and union. We will discuss these data types further. Okay, so all these are data type instructions. So there are no instructions for array, pointer, and function. Okay, we have got operators for pointers like asterisk and ampersand. So these are pointer based operators. Okay, so this asterisk is called dereferencing operator. Okay, and ampersand, I have already told you, it is called address of operator. Right? So, and for these are all keywords: character, integer, float, double. So there are these keywords. So enumeration, enum, is also a keyword will be used for defining enumeration. Then we have got keyword for structure as struct and for union as union only. So there are keywords for that. But for array, pointer, and function, we have to rely on this primitive data types. Right? So these are the different data types which are available in C language. Arithmetic instructions you have used several times in your program, although I will tell you. So all these instructions can be binary operators. Binary operators means two operands should be there. What are operands? Operands are values on which an operation is performed. For example, if I write a plus b, so here plus is called an operator, and a and b, they are known as operands. Okay, they are known as operands or values. Okay, so this is operand is nothing but data, and operator is nothing but instruction. Okay. So here, if I'm using two operands, so if my operator takes two operands, then this operator is called binary operator. And if my operator takes one operand, it is called a unary operator. If my operator takes three operands, then it is called ternary operator. So an operator can be binary, unary, or ternary. Ternary means three operands. So when we talk about addition, subtraction, multiplication, division, modulo, they are all binary operators. Binary operators because they will use two operands. Means you will write a plus b, a minus b, a into b, a divided by b, a modulo b. You will use such instructions. You will use such values. Okay. But if you want to have a increment decrement operation, so for increment decrement, you will be using unary. So unary means a single operator. So if I'm writing I plus plus, so that is equal to I plus 1. So I plus plus here, unary plus you can use to perform addition. So there is only one operator which is present. Okay, there can be a unary minus for performing subtraction. So if you want to display sign, for example, plus 2 or minus 2. So in that case, plus 2 minus 2 will display the sign of your value. So it is called a unary minus. Okay. So if I want to subtract two numbers, I can write a plus minus b. So a plus minus b will become what? A minus b. Is it right? So in that case, I'm using a unary operator. Is it clear? Then we come to data manipulation instructions. So when we talk about data manipulation instructions means you want to change or update or manipulate any value of the variable. So if you want to manipulate or alter the value of a variable, then the instructions which we use for that is called data manipulation instruction. So data manipulation instructions are categorized into three types: arithmetic instruction, logical or bit manipulation instruction, and shift instruction. Okay. So first is arithmetic instruction. So arithmetic instruction, I have already told you, we can perform arithmetic operations like this. Okay. So what is the difference between a divided by b and a modulo b? Since division can generate two outputs, a divided by b will generate a quotient, and a modulo b will generate remainder of the division. Okay. For example, if I do 5 divided by 3, 5 oblique 3. So what will be the output? Output will be 1 because 3 will go 1 times in 5. But if I write 5 modulo 3, the output will be 2 because the remainder of 5 modulo 5 divided by 3 will be 2. So this is remainder and this is quotient. Okay. Okay, is it clear? Then we have got a logical and a bit manipulation instructions. So logical instructions means what? There are different logical operators: and, or, not, XOR. Okay, using and not you can use NAND. Using or and not you can use NOR. Okay, you can use XNOR also. Using NOR and XOR you can make XNOR. Okay, but primarily speaking, these are the four basic logical operations. So for AND we use, so if it is bitwise means it will consider these two values as binary values. So bitwise operations will require your integer to be converted into its respective binary. So for AND operation, bit manipulation operation, we use single ampersand. So this sign is called ampersand. Okay, this sign is called ampersand, right? For OR we use a single pipe. This is called pipe symbol. Okay, and for NOT we will use the tilde sign. This sign is called tilde. Okay, for XOR we use this sign. This sign is called caret sign. So these are the different sign which we use. So AND is used for A ampersand B. So now how it is calculated? A ampersand B. So A is 5. So the binary value of 5 is what? 101. Do you know this? How to calculate binary of 5? Okay. So you divide it by 2 iteratively. 2 2s are 4. The remainder is 1. Okay. 2 2s are 2 1s are 2. Okay. So remainder is 0. So now you go from bottom to top. So the value is 5 in binary. Similarly, if we talk about B as 3, so the binary for 3 is what? 0 1 1 or simply 1 1. But since we have to equal the number of bits present in both 5 and 3, I have added a prefix 0. So the binary of 3 is 1 1. So 2 goes 1 times in 3, the remainder is 1, and 2 goes 0 time in 1. Okay. So the remainder is 1 only. So if you talk about this, then it is 0 1 1. Or you can stop here. You can stop here also. No need for that. So simply it is 1 1. But if you want to go further, you can add as many number of zeros as you want. So here, if you do an AND between the both the values, so 0 1 1. So if you do an AND between them, AND means what? 1 and 1 is what? 1. 0 and 1 is what? 0. 1 and 0 is what? 0. So the answer is 1. So 1, 5 and 3. The answer is 1. Why? Because it is 0 0 1. Clear? Now if I want to calculate 5 or 3. So what is 5 or 3? Do an OR between them. So what do you get in that case? So in that case, how do you calculate? 1 or 1 is 1. 0 or 1 is 1. 1 or 0 is 1. So 1 1 1 is what? 7. So that is why you get here 7. Similarly, if you do an XOR between these two, 1 0 1 XOR 0 1 1. So 1 XOR 1 is 0. 0 XOR 1 is 1. 1 XOR 0 is 1. So 1 1 0 is what? 6. So that is why you get here 6. Now this complement is a unary operation, means it will just reverse the number of it will just interchange 0 with 1 and 1 with 0. So this is called complement. It is called complement. It is not normally called not. It is called complement because it will change 0 to 1s and 1s to 0s. So if you are doing a complement of A, it means that you are complementing 1 0 1, or I should say 0 1 0 1. So what it will become? 0, 1, 0. Okay, so but it will take 2's complement basically. So when we talk about tilde sign, it is not 1's complement, it is 2's complement. So what is 2's complement? You add 1 to 1's complement. You take 1's complement and you add 1 to 1's complement, then you get 2's complement. Okay, that is how you get 2's complement. Now, how to take 1's complement? 1's complement is nothing. You have to change zeros to ones and ones to zeros, right? Ones to zeros and zeros to ones. So that is how you convert these values. Okay, so then you get one's complement. But if you are doing two's complement, then it will add one to your value. Okay, so when you take two's complement, what happens? The sign is inverted, the sign is reversed. Okay, in two's complement, the sign is reverse. The sign is reversed, right? So here we are calculating not of 5. Yeah, it means we are calculating 2's complement of 5. Okay, so this is how we calculate 2's complement of 5. So we have to calculate 2's complement of 5. 2's complement of 5. So 2's complement of 5, how will you calculate? First of all, you have to write positive plus 5. So plus 5 is what? 0, 1, 0, 1. Okay, so 2's complement, if you take 1's complement of this number, then what do you get? 1, 0, 1, 0. Okay, this is your 1's complement. So this is how you get 1, 0, 1, 0. Okay, but this 1, 0, 1, 0 is minus 6 basically. This 1, 0, 1, 0 is minus 6. How will you prove? How will you prove this that 1, 0, 1, 0 is minus 6? First you check for plus 6. So what is plus 6? 0, 1, 1, 0. Then you take 1's complement of this number. So 1's complement of this number will become 1, 0, 0, 1. And then you add 1 to it. Take 2's complement. So you will get 1, 0, 1, 0, which is minus 6. Okay. So this is how we can prove that this is 2's complement. Okay. So the complement of plus 5 is minus 6. Right? Hope it is clear to you. If it is not clear, let me know in queries. Is this example clear to you? Why it is minus 6? Okay, many students are replying yes, sir. Okay, fair enough. Other students are not participating, maybe due to some reason. Okay, great. So here we have got shift instructions. So what are shift instructions? So shift means to shift a number left or to shift to a number right. Okay, so shifting can be of in two directions. Left shift. So left shift is demonstrated by two left side less than sign values. So this is called left shift. Okay. Similarly, we have got right shift. Okay. So left shift is what? Multiplication by 2. And right shift is division by 2. Okay. This you have to remember. So if you do a left shift, you will multiply by 2. For example, if I take a number, let's say if I take a binary number as 101. Okay. 0101 maybe. If I do a left shift means a number gets shifted like this. So in order to shift left, if we want to shift a number to the left, I will insert a 0 to the right. I will insert a 0 to the right for left shift. So if I insert a 0 to the right, this number will be lost. This number will be lost because it will fall down. Okay, imagine some students or some students sitting on a bench. Okay, if you add, and this bench has got a capacity of 4 students maximum. If you ask a student to get inserted at the right, let's say there is a student who gets inserted to the right, what will happen to this guy? This guy will fall off, and with this we have got 4 students on the bench. So if you have got a number like 0101 and you insert a 0 here, so this number will go away and this number will be what? 10. 0101 was what? 5. So what is 5 to 10? It is 2 times. So if you do a left shift, you do by inserting a 0 on the right, then this will result in a multiplication of 2. In the same way, if you do a right shift, so right shift means inserting a 0 to the left. So if you insert a 0 to the left, the numbers will shift towards the right, which will result in division by 2. For example, if you have got a number as 1010, let's say this is the number, which is 10 in decimal. So if you insert a 0 to the left, what will happen to this number? This number will go away. So you will get 0101, that is what? 5. So what is 10 to 5? That is division by 2, right? So if you left shift a number by 1, means by 1 position, you can do a left shift by 1 position, 2 position, 3 position, any position you can shift. So let's say if I am just shifting once, so I will write 5 with a left shift of 1. It means only one number will be inserted. Means you will multiply by 2 only once. If you want to multiply it by 2 times, then you will write left shift by 2. So in that case, what will happen? 5 will be multiplied by 2 once, and then that number will be again multiplied by 2. So 5 will be multiplied by 4, basically. Okay. Is it clear? So if you have got a number like 1010, and then you again shift it towards the left, so what will happen? You will get a larger number. Okay. The problem is you cannot get away with this one because that will increase your number. So this is 20. Okay. 0, 1, 2, 3, 4. So this number is 20. Okay. Because from you have started with 0101, then you got 1010, and then you have got 10100. You have added 10 again to the right. Okay. So this has multiplied by 4 times. So 2 times here and 2 times here. So this was 5, this is 20 now. So this is the result of this operation, left shift. Okay, so let's take an example. Let's do a left shift on 21. So if I write 21, so 21 is left shifted by 1. So if I write 21 left shift by 1, what will happen to this number? 21 is left shift by 1. It means 21 will be multiplied by 2 raised to power 1. So that will be 42. So if 21 is written like this, 10101, and if I perform a left shift, so what will happen? In that case, I have to uh, add a 0 here. Okay. I have to add a 0 here, right? So now this will become 42. Okay. Is it clear? So this number will be 101010. So that is 42. If you want, you can check 0, 1, 2, 3, 4, 4, 5. So 2 raised to power 5. Okay, plus 2 raised to power 3 plus 2 raised to power 1. So 32 plus 8 plus 2. So that is 42. Okay, so this number is 42. Is it clear? Similarly, if we are doing a right shift, in that case, what will happen? If you are doing a right shift, how will you write it? So let's say if I write 21, sorry, now I have to reverse the arrow, right? 21 divided by 21 with one right shift. So that will result in 21 divided by 2. So that will give me what? 10. That will give me 10. So only quotient will be considered. Okay. Or if I write 21 right shift by 2, it means what? 21 divided by 2 square. That is 4. So it will give me 5. So that will be my answer, 5. So that is written as 0101. Okay. So this is how you do shift instructions. Is it clear? So here we have got an example. Okay, we have got this number 21. Right, you don't have to write this in bracket. I'm just telling you what it internally takes. Okay, so we can do left shift and right shift operations like this. Then we come to program control instructions. So program control instructions can be classified as branching statements, iterative statements, and jump statements. So these are all control instructions. Okay, so branching statements or conditional statements, these are also known as conditional branching. Okay, and these are known as jump statements are called unconditional branching. Okay, unconditional branching. So conditional branching means it checks the condition basically. So here we check a condition and based upon its true or false, we take a branch or we generate a branch. So the condition is checked first and then only we can branch. Branch means to skip or to continue or to execute some block of code in between. Right. So there are if else, if else if and switch. So these are all conditional branching statements or selection statements. For iterative statements, these are also known as loop control statements. So there are three looping statements present in C language: while, do while, and for. Okay, and we have got unconditional branching statements present in C language like break, continue, and go to. So these are different program control statements present in C language. Okay. Till now, I think it is clear to everyone. Okay. Hopefully, you are able to understand till this point. So we have already studied decision control statements. Okay. Here we consider a small case for your understanding. Let's say there is a website you are trying to log in and you enter wrong ID and password and it is displaying an error page which is saying that login unsuccessful. Okay, you have seen such pages? Login unsuccessful. Okay. But if you enter correct credential, it goes to a welcome page. So how does this difference is there in output? Why is there a difference in output? Because based on some condition evaluation, some condition was checked, some logic was there which checked the condition. If the user ID and password both are correct, then only the user will be granted access to the home page. Otherwise, user will be stopped there and will be having a message as login unsuccessful or incorrect user ID password. Okay, similar messages are shown. Why? Because an authentication mechanism is there. A condition is checked. If both ID and password, there's a logical condition. Both ID and password has to be correct. Then only you will be granted access to your application. So how is this happening? How is this logic written? Based on a decision control statement. Okay, so decision control statement enables us to check a condition, and on the basis of the evaluation of that condition, it can take a decision whether to grant access, whether not to grant an access. Okay, so this is an application of decision control statements. So I've already told you the decision control statements or a conditional statements. They are if, if else, nested if else if ladder, and switch case. So these are the different decision control statements available in C language. Okay, so we are going to study till this point. We will continue decision control statements in the next lecture. Okay, till now, if you are having any doubt or any query, you can ask. Okay, please feel free to ask any query or doubt. Okay, we will discuss all this topic. Okay, now I have got some review questions for you to check. So you tell me what are type declaration instructions. Please respond on chat. What are type declaration instructions? Please reply. What are type declaration instructions? Keywords, right? Keywords like integer, character, yes, float, yes. Integer, character, float, very good. Double, right? Void. These are type declaration instructions. Okay. Now, what are the different type of type declaration instructions? Max. What is max? Okay, format specifier. Format specifier. What are format specifiers? Which in formatted input output instruction you specify format, right? So %f, %d, %lf, capital LF, %u, %s. These are all format specifier. Okay. Okay. So students are saying const is a type declaration instruction. So const is not a data type. Const is not a data type. Const is merely a keyword but a constant should also have a data type. So after const also you have to mention the data type. Okay. So it is necessary for you to mention the data type even after writing const. So if you are writing a data type after const, it means that constant is not a data type. Okay. So const is simply a way to declare a constant. Okay, and that constant can be of any data type. It can be a numeric constant, it can be a non-numeric constant. Okay, so if you are relying on a data type instruction for defining your const keyword is not a data type. It's simply a keyword which differentiates between a constant and a variable. And if you don't write constant, automatically your data type will be translated as a variable's name. Clear? All right. So hopefully you must have understood about these all topics today. Uh, that's it for today's session. Thank you and happy learning.